Welcome to another session of Solve with Techsolvi. Today we are going to solve this three-sum closest problem. This is a very interesting problem among two pointers or pointers group of problems, and we will see how to solve this today. So let's read the description and let's understand what the problem is all about. Given an integer array of length n and an integer target, find three integers in nums such that the sum is closest to target. Okay. Return the sum of three integers. You may assume that each input would have exactly one solution. Okay. So what it's trying to say, basically among given a list of integers and also a target value, we have to find three integers from the list whose sum tends to be closer to the target. Okay, and can be equals to target also, but need not necessarily equals to the target. So let's look into the examples given. So here given the nums and the target 1, the output is 2. Okay, so here we can see the sum of the numbers is greater than the target. Okay, so that can also be a possibility. Okay, and this being the closest, so they have responded with this value. In the second example also, there are only three elements, target is 1, so obviously the only possibility was 0 because sum of all zeros is 0, and that's the only possible solution in this scenario. Let's look into the constraints. So you can see the length of the array goes till 500, and the values of nums are actually ranging from negative to positive. This is an interesting thing to look into. And the target is also from negative to positive. This is a key observation here. We'll see how it is key observation. Okay, so let's dive into the problem solving approach. So here what we have to do is that let's create a block comment section. So given nums, let's copy any one of the nums. Okay, so basically we are looking for three numbers, I, j and k. Okay, so the approach will be quite standard here, that we'll fix one element, say I will fix, okay, and then we will play with j and k. Okay, so we are eventually trying to find a sum, okay, which will be equals to I plus j plus k. This is not the sum of the indexes but sum of the index value, so it's a representation. When I'm mentioning that is I, that means it's num of I. Okay, so consider it like that instead of taking index values. Okay, so this is what we are looking for. Okay, and also we have a target. Okay, so once we fix I, okay, as we fix I, what will happen? Target will be target minus nums I, right? So this is a new target that will be chasing across in the list using the help of two pointers. So one thing we have to observe that basically since we are looking for sum, we have to place, if this is the array, okay, let's copy the values in fact. Okay, we need to have one pointer over here, say p1, and another pointer will be say p2. Okay, but if you are aware of the pointer approaches, you should also be aware that to place any pointer we need to have some kind of relationship within the elements of the array or some kind of arrangements. Okay, here we can see the elements are not arranged in any order, things are in random. So in a random element arrangement, pointers approach doesn't work because we need some logic to move the pointers, and if the elements of the adjacent elements have no logic among itself or no rules among itself or no relationships among itself, obviously we can't move the pointers logically. So hence we have to sort it. So let's sort this. Okay, so if I sort this, what will come? First will be -4, okay, then -1, then 1, and then 2. Let's delete this 2, not required. So this is a sorted list. So if we have a pointer p1, p2, okay, p1 will be at this location, p2 will be at the last location. Okay, now what will be the pointer movement logic? Pointer movement logic is that we are looking for sum. Say sum equals to p1 means, or you can say nums p1, okay, plus nums p2. Okay, so if sum by say, if sum means, suppose here the sum is, suppose consider this sum as -4 plus 2 is basically nothing but -2. Okay, and our reference point will be that this difference. Okay, so we need to also have a reference point. The reference point will be difference. Okay, let's write the difference. Difference will be nothing but absolute difference of target minus sum. Okay, so if we see, if our difference is increasing, okay, if my difference is increasing on moving pointer p1 by +1, increasing for p1 plus plus, or let's write it in a different way. If difference is decreasing p1 plus plus, okay, then we will do p1 plus plus. Okay, or what we can do is that okay, since the target is positive, okay, so okay, what we can do, let's consider diff only. Okay, let's, okay, so if diff is decreasing for p1 plus plus, we'll move the pointer p1 plus plus. Otherwise, else if we'll check if the difference is decreasing for p2 minus minus, okay, then we'll do p2 minus minus. Okay, otherwise, if nothing, no movement of the pointer is actually impacting the difference, then what we have to do by default, we have to move both the pointers in their own directions, that is p1 plus plus and p2 minus minus. Okay, so this will be our logic for pointer movement. Okay, so let's dive into the coding part. So if whatever is whatever doubt or question mark part are there, hope that will get clear while coding. Okay, let's start. So first we have to do is that sort nums dot, okay, we have sorted it first thing. Now we need to fix the index of I will be 0. Okay, now let's have a min diff. Let's take some higher values. Now how to take a min diff? Okay, so you can see the range of target is 10 to the power 4, right? 2 minus 10 to the power 4. So and the numbers are ranging from this -1000 to 1000. So what can be the worst scenario? Say suppose 10 to the power 4 minus, say, let's say all the numbers are negative, and let's take the least possible values, that is -1000 into 3, because 3 numbers we are looking for, so that will be basically 3000. So minus minus, it will become eventually plus, right? So what's the value over here? Difference is becoming something like 13,000, right? So 13,000 is the maximum possible difference that can come up based on the ranges or the constraints given. Okay, so with this figure in mind, we can set up our initial mean difference to a higher value. Okay, so what we'll do, instead of having 10,000, we'll do 1 lakh. So we have seen that now this number will never get crossed. Okay, this is the highest possible value within this limitation given in the constraints. Okay, so and also we need a sum of numbers. Sum of numbers, let's consider as 0 as of now, because anyways we can start with any sum, because this is not a point of reference or point of comparison. In fact, as you will see, we will compare only mean diff down the line. So let's write a while loop. What should be the condition on the while? While will be so we are iterating on the I. Okay, first we will give the constraint on I. I will be length of the nums. But will it just be the length of nums? No, because we have other 2 pointers to place. Okay, so we if and the relationship between the pointers are like this: I is less than j and is less than k. Okay, and with this relationship in mind, what can be the maximum index up to which I can crawl up to? It's obviously num minus 2, right? So okay, we have set the ground for I. So what will be the j for I? J will be obviously I plus 1. Okay, what will be the k? K will be the last index, as you have seen. It will be at the end. So len of nums minus 1. Okay, now we have to set the logic for the second loop. So it will be while j less than k. So as I mentioned, this is the relationship we are following. So obviously, as long as j is less than k, we will keep on iterating. Okay, now we got the rules set for the loops. Now we have to compute the diff. Okay, diff is nothing, as I mentioned, abs of t2. What is t2? T2 is the new target. Okay, let's define t2. T2 equals to target minus nums of this, what is nums of I, right? So this is the new target that we are chasing for the other 2 values, okay, from the list. So t2 minus nums j minus nums k. Okay, so this is a new diff. Now we have to check whether this diff is the minimum diff or not. If diff is less than mean diff, okay, so what we have to do, mean diff we have to update the first thing, and also we have to update the sum. Sum equals to nums I plus nums j plus k. Okay, so we also got the updated sum. Now we have to give the logic for updating the j's and k's. Okay, so now if as we discussed, in fact let's copy it. Okay, we can't copy it. So if diff is less than, let's copy this one at least. So we are checking if by incrementing j, if my diff is my diff increasing. If it's increasing, then obviously we can't go ahead, or rather we can check in a different way. If the diff by increasing j, if my this absolute value is decreasing, then that's a favorable scenario for me, right? Because we want to reduce the difference. So obviously j minus equals to 1 I will do. Otherwise, let's copy this again. Otherwise, if by decreasing k minus 1, if my diff is decreasing, okay, compared to the current diff, then I will do k minus equals to 1. Okay, here it will be plus equals to. Okay, now otherwise if none of these the above two conditions are met, then what to do? Then what we will do, we will both increase j and reduce k. Okay, basically we will reduce the search space. Okay, j plus equals to 1, k minus equals to 1. Okay, so also, so I have laid down the rules for moving the pointers. Okay, now once this is done, what we can do is we have to increment the I plus equals to 1. Okay, so I think that's the rule set. Now we have to respond out with the sum value, return sum. Okay, one thing we can do, we can also check if the diff is 0, because if diff is 0, that's the least possible diff we can ever have, right? So let's check if diff equals to 0, then we can right away return sum. We can avoid all the remaining computation because we have reached the least possible value. Okay, so let's try. There's some syntax error where it is else. Okay, okay, this got accepted. Let's submit. So it got accepted. Hope you like this session. Don't forget to like and subscribe and stay tuned for more upcoming problem solving sessions.